Question Q1 of homework number 2 states that a guitar string has length L and mass M and is attached between two stops that are a distance d apart. Part A wants us to find a value of tension that will produce a standing wave with fundamental frequency F. In this expression, we have to use these four given quantities, L, M, D, and F. So here you can see I've written out these four values. L is the total length of the string in the guitar. M is the mass of string. D is specifically the length of string between the bridge and the nut. And F represents the fundamental frequency. So in order for us to find an expression for T, we should first find a formula that has T in it. The first equation I can think of is the formula for velocity, so let's write that down. E equals tension over mu. And now we need to isolate T, so let's start by squaring both sides. V squared equals T over mu. And then multiply by mu to isolate T. So T is now V squared times mu. So already you can see in our expression for T, we've satisfied the requirements for mass and length because the units for mu are mass over length. So we don't need to worry about these two. And now we still need the length of the string from bridge to nut and the fundamental frequency. Since you're given velocity here, just keep in mind that D is a unit of length, F is a unit of time, and so that tells us we should probably use the D equals RT formula because it relates all three of those variables. D equals RT. We can start off by finding the fundamental frequency by substituting D with the fundamental wavelength, and R with V, as it's meters per second, and then we can keep time as is for now. And now let's rewrite V as fundamental wavelength times 1 over time per unit time. And notice that this matches the units for frequency because frequency is always 1 over a unit of time. So now we can rewrite this as velocity equals the fundamental wavelength times the fundamental frequency. And now we have this in our equation. So that's done. We still need the length of the string from bridge to nut. So let's try to do that by getting rid of this first. Let's rewrite it as V over F. We know velocity is tension over mu. And the fundamental frequency is mass over 2 times the length of a string bound between two ends, which is D in this case, not L, because L is the total length of string, times velocity. These two cancel out, and now you get 2D over M. Since this is the fundamental mode, M is just 1, and so the fundamental wavelength is equivalent to 2D. Now we have all of our known units in our tension formula, or our tension expression. Let's just rewrite the whole thing. Tension equals velocity squared times mu. And we said that velocity was equal to the fundamental wavelength times the fundamental frequency. So let's write that. And then this simplifies to fundamental wavelength squared times the fundamental frequency squared. And mu, let's just write that as mass over length. This can stay we'll substitute this with 2D. So this becomes 4D times the fundamental frequency squared, this is also squared, times mass over length. And that is our expression for tension.